Has started.
So welcome to the Impromptu BioC Developers Forum. So I think today we're going to start. I wanted to just briefly overview the release schedule and important dates and maybe a couple comments of why we do them, when we do them. Because bad timing on my part, I figured I could do it in October release forum, but that would be the Thursday directly before the release, and we've already would be through like the current release branch freeze. So thought it best to at least mention it and offer it up for questions now instead of having to go through the mailing list. I'll just share my screen, hopefully. And you all see the release schedule?
Yep.
Great. So some behind the scene things that are not actually listed on this page. So we've already begun the process of building the annotation pipelines for DB0s and resources for ORGDBs and TextDBs. So the process has started for that, and as soon as they are built and on the builders, then we would contact everyone letting them know that they're available, and any packages that utilize those could start updating for the next release. So that's started just behind the scenes. So the first big deadline that's coming up is Friday, October 2nd, which is a week from tomorrow, I believe. Yes. And that is the deadline for new package submissions to the Bioconductor submission tracker. And what we say is for that to be included in this next Bioconductor 3.12 release. So currently the core team handles package reviews, and there's 6 of us, and we have a lot of other tasks also. So we try to say a 4-week deadline out from the release to have a fair shot of getting you a review and having time for maintainers to actually take in the comments from the review to try to get it accepted. You can still submit packages after this date. We just can't honestly say that we'll have time to get to them. And there is a shot that we may, but we just kind of put this out there to give us kind of a breaking point of what ones we try to work and interact with the maintainers to get through and accepted by the actual release date. Monday, October 5th, I'll announce the final list of deprecated packages. They'll be deprecated in the release 3.12 and removed in the upcoming 3.13 release. So those could either be for unresponsive maintainers or user requested. I do keep the support site thread list of deprecated packages for 3.12 fairly updated. So the final list will go out on that Monday for packages to adapt as well. The big one, our current release 3.11 will be frozen on Tuesday, October 13th. And so commits to the release 3.11 branch will be disabled permanently. So there'll be no changes from here on and into the future for any package on the release 3.11 branch. So over the course of the next week or two, the Bioconductor core team splits up the entire list of packages that are currently in Bioconductor and will reach out to any package failing on release to try to clean it up by this date so that we can have working packages for all platforms when it's frozen. We need to do this switch a couple weeks before the actual release because the current builders that are building the 3.11 will become the new build machines for 3.13. So that's kind of the idea of why we freeze this branch earlier so that we can have a switch and develop builder up when we do the actual 3.12 release. Wednesday, October 21st is a week before the release, and we say no API changes, and also that's the deadline for any package in the new submission tracker to be added to the manifest. This allows packages to go through at least one nightly build, if not 1 or 2, to make sure that everything's building okay before the release and give a last chance to fix any bugs before the actual branching from devel to release. Friday, October 23rd is pretty much the deadline for making sure your packages build and check without errors or warnings. And again, this is so that it can get through the nightly builder without being branched, without actually being tested first, and saves maintainers potentially the trouble of having to fix bugs then on a release and develop branch. Monday, October 26th would be the last day to commit any changes to the 3.12 branch before they're frozen. We also say that that's the date that your news files has to be updated in order to be included in the release announcement. When we do post the release announcement, we collate all of the news files from all of the packages that have made any changes or acknowledge any changes in their news file to be announced. And then the branches will be frozen at some point during that day, Tuesday. So the branch gets frozen on Tuesday, October 22nd. Nitesh will normally make an announcement giving like an hour heads up before the branch is officially frozen. Commits will be disabled for an hour or two while the branching takes place. And then that allows us to have the new branch to put through for the build report. And then once all the package go through the build and check process and have a build report, we announce the release on Wednesday, October 28th. And then after the fact, we obviously create AMIs and Docker files for the new branches and new versions of packages. So that's a general overview. Did anyone have any questions or concerns or issues that they wanted to ask now? Wonderful. So hopefully here's to an easy and smooth release 3.12. I will also just mention for people too, one of the reasons why we do the release in the fall, the biannual release, at this point when we do switch, the devel builders for 3.13 will be building off of our devel. And part of the reason why we do this is to prepare for the R release in spring. That way, packages have time to adapt to any big or breaking changes in the R code base in devel over the next 6 months. And we try to keep the R devel patch, we try to update it monthly so that packages can adapt as quickly as possible. With that, I guess I will turn it over to Martin for the second half of today's developer forum.
All right. I'll mention just that R will come out with a patch release 4.03, and I think it's going to come out on the 10th of October. Usually we try and sync a little bit more closely with when their release is and when our release is, but we'll be a couple of weeks behind. So you might want to, if you're a fanatic about making sure the version that your packages are built are consistent with the version of the R that you're running on, you might want to hold off on upgrading your R 4.03 until closer to the Bioconductor release. All right, Anvil, great for people to show up, and I guess it's going to be just a little bit ad hoc. Here's my screen, I hope. At anvilproject.org. This is an NHGRI, National Human Genome Research Institute funded project. Basically, the NHGRI generates some very large data sets, and they've realized that the usual way that these have been analyzed is to move the data from wherever they've been created to the local institute and then doing computation there. Of course, this is a pretty boneheaded way of doing computation, especially as the data sets get large. So the overall goal is to host the data and the compute environments in the same approximate location. And they've chosen to host data and compute resources for this particular project in the Google computational cloud. So there's this combination of large data sets coupled with computing capabilities, and then ways of analyzing the data that are sort of combined into Anvil. So this kind of platform components diagram is trying to get at some kind of overview of how things work. Gen 3 is the underlying data store where these large data sets are housed. There's something called Doc Store, which manages workflows, formal workflows written in the workflow description language, WDL. And then there's Terra, which is the compute environment, and that couples data access and workflows, as well as more familiar things like Jupyter and the Galaxy, RStudio and Bioconductor, into an environment where you can do computation. Both workflows would be used for processing hundreds of gigabytes of data, usually data reductions, and then more analysis in tools over in this corner of things. So that's kind of the big picture. I should say also that the motivation from NHGRI was really managing these large data resources, but from the Bioconductor perspective, I think that it's clear that we're increasingly involved in cloud computing, that the day of the laptop is fast coming to an end. And so it's a useful environment, even if the match between what the motivation for the Anvil and what Bioconductor does isn't exactly perfect. I think it's a good opportunity for us to kind of start playing in that environment. So I'm pretty excited to be able to participate. This tab is a data explorer, and it gives you a sense of the types of data that are available. And maybe for some of you this might not mean anything, but there's 1,000 genomes data, CCDG, CMG, eMERGE, and GTEC. These are all large-scale genome projects with many thousands of subjects and samples, and data that is large in total. And often the data requires controlled access, like not anyone from the public can access those resources. And the Anvil provides a way to get access if appropriate. And you can see that only one of these projects, the 1,000 Genomes project, provides open access. And then different types of data, and then the individual 1,000 genomes data. This is a description of it. I was hoping actually to end up with information about like the sex of individuals, their ethnicity, and so on. And you might be interested in accessing a subset of the data or different facets of the data. And the Anvil provides that kind of functionality. So this is kind of like big data, but you could also think, well, maybe I've got smaller data like my own RNA-seq experiment or single-cell experiment that I want to analyze using cloud-based resources. They're not restricted to this large-scale data. And then the current tools that kind of fall into two broad classes of readily available tools. This WDL, the workflow description language, which is like for wholesale analysis of large data, and then a Jupyter environment that includes Python and R kernels in the background. And then it's actually also possible to use RStudio from within the Anvil. So I'll talk about that just a little bit. So all right. Sorry about that. Big data tools for working with it, and the data could be restricted, and you'd have still, if appropriate, you'd have access to it. Okay, people with me so far? Nod your head. Some heads nodding. That's good. Okay, so now I went to anvil.terra.bio, and this is like the entry to the cloud-based computing environment. And I'm actually going to, since it's lunchtime, I'm going to go up to the hamburger menu. This is, all of this is just noise to me mostly, but under the hamburger menu, I've logged in with an account. I'll sign out and log in again. It'd be really exciting. So the idea is that, so it's a cloud computing environment, and that actually means that you have to pay for it. And to pay for it, you need to have a way of doing the accounting. And since we're using Google, what better way of Google knowing how to bill you than billing your Google account? So I'm going to sign in with one of my Google accounts, and then in my profile it says this is who I am, this is my account, and furthermore it knows about my credit card information. So I'll actually be billed for the computing that I do. I was going to say two things. One is that when you sign up for Google, you get $300 of free credit, and actually you can do a lot with $300 worth of cloud computing credit for the type of work that we do, so it shouldn't be a deterrent for the initial exploration. And then I also wanted to say that it's with some work, if you're using this as your main research platform, you could arrange for like your institution to have a contract where the compute costs were paid by purchase order, and so it's like just any other cost that was on a grant. It wouldn't be coming from your credit card or anything like that. So just going after that idea. And then after going to the hamburger and signing in, I usually go to your Workspaces, and this is how the Anvil is organized. There are these different workspaces that kind of combine data and compute resources for those for different workspaces. And there's some that are public, some that are featured or new and interesting, and then my own workspaces, but some of which are public workspaces that I have made my own. And because this is Bioconductor, I was going to look for Bioconductor workspaces, and it turns out that this is still a kind of a work in progress, right? So these are just some of the workspaces that we've been developing over the last little while. For instance, I did a workshop with the Bioinformatics Community Conference, and the resources are here. And Seyun did a workshop at the Bioconductor conference, and actually that material is here as well. And I'm going to open this one just for a little bit and just take a quick little exploration. So every workspace starts like this. It has a dashboard, and then the data resources, notebooks, and workflows associated with this workspace. So the dashboard is it's a markdown document, and the person who created the markdown can put whatever they want here. So actually, Seyun's work is based on a publication, and it's kind of like an example of reproducible research, right? So the publication is actually captured, the analyses are actually captured in this notebook or in this workspace. And she's provided an overview of how things work. And then this, without getting into like the gory details, starts with the essence of big data, so bed files and FASTA files and BAM files. And then it's processed through a series of workflows written in WDL down to files that are manageable and that can be incorporated into R packages and analyzed in Bioconductor. So at some level, she's identified the individuals that are going to be included in the analysis, and it's included under this data tab. These are the individuals, I think, from the 1,000 Genomes Project that are going to be used in her analysis. And these are links to the data. I'm not sure if you see the pop-up. It's probably too small, but it starts GS://. It's data that's in a Google bucket, so it's cloud-based data. And then she has written a number of workflows that implement that complicated diagram that she had and do various transformations. And each of these workflows operates on, I hope to come back to this in just a second or so, operates on some of those files, transforming them in steps that could involve R or could involve something else. And these workflows are written in WDL, the workflow description language. So this is, the workflows kind of do the big data analysis, and they come from DocStore, and DocStore uses GitHub, so they're all sort of GitHub based and have provenance in that way. And then once the workflows have been run, the data are more manageable, and Seiyun has a number of notebooks that can be used to analyze or perform the next step in the analysis. So if you look at one of these notebooks, just an arbitrary notebook, you'll see that it's a Jupyter notebook. Jupyter notebooks are kind of like Markdown, I guess, with these cells that can be, press, carriage, return, blah, and it'll be evaluated, and the various commands in the cells will be performed. So she's doing a bunch of setup, I think, for the analysis here, and then finally reads in the mutation signature file that was the product of one of her workflows. So there's kind of like these two different ways of doing work on big data using workflows, and notebooks for more interactive analysis. So how are we doing? People following along? Nodding heads. All right, great. So I was going to look at one of these guys as just to be a little bit more concrete. I was actually hoping to. What do I got over here? I was actually hoping to show a different one, but we'll go for it. So actually the one that I was hoping to show is something that Kayla and I are just working on at the moment, and it's kind of like maybe a more familiar and simpler scenario involving bulk RNA-seq. And you can think of like bulk RNA-seq, say DE-seq2 is like the package that you'd use, and you'd maybe develop a notebook that represented the DE-seq workflow and exploratory analysis that was kind of typical for bulk analysis. So that would be like a notebook. But then in a bulk RNA-seq analysis, there's also a kind of big data, not so big data transformation where you go from FASTA files using things like Salmon or Callisto to count matrices. And that's kind of like a big data transformation. So Kayla is working on a workflow that does the big data Salmon analysis of and reduction to count matrices, and then also a notebook that reflects the DE-seq vignette standard operating procedure. So that's kind of maybe what you could imagine that you say instead of constructing your own bulk RNA-seq analysis from scratch. You'd instead start with Kayla's workspace, clone it, and customize it to your data. Bring your data into the Google Cloud, click on the workflow button, run the Salmon workflow to get count matrices, then open up the Jupyter notebook and work through the analysis, the R-based analysis. Kind of the idea. These things, Bioconductor Package Anvil, Bioconductor Package Anvil Billing, Publish, Gen 3, Ontoproc. These are actually R packages. Some of them are actually in Bioconductor. So there is the Anvil package in Bioconductor, and there will be an Anvil Billing and Publish and Gen 3 package in Bioconductor. And if you look at the Anvil Bioconductor package, you can see that we've got the title, we've got stuff that you might recognize as being scraped from the description file of the document, including the author, maintainer, license, version, the description, and then some basic instructions about how you're supposed to use some vignettes and who the authors are and how to cite the package. And then in the notebooks, you have, these are actually, this is something that I've created myself, but this is actually the vignette from, somebody asked about renaming and I renamed my vignette. So this is the vignette from the Anvil package that illustrates how you're supposed to use the Anvil package to do things. And maybe the point here actually is that it's the vignette translated into a Python notebook, which is kind of interesting, right? So you take the vignette, turn it into a Python notebook, and then it's available in the Anvil workspace. And actually this package, Anvil Publish, automates the process. So it's like a one-line command that takes any Bioconductor package with a markdown vignette and translates the vignette into and the package into a workspace. So for instance, just, it's always fun to bootstrap these things. So this Bioconductor package, Anvil Publish, was actually the entire workspace was produced by the Anvil Publish package, right? So no human intervention required other than pressing a magic button. So it sort of bootstrapped itself. And here's the vignette from the Anvil Publish package. Should be here in just a second. It's waiting for something on the other end of things. I'm not going to wait for that though, although it's going to make me wait. And now my Chrome seems to have frozen. Right. So that's actually kind of fun. This Bioconductor package, Ontoproc, is a package that Vince has created for annotating cell lines and so on from ontologies. And it's just a Bioconductor package that he has used Anvil Publish on to create a workspace based on the package. So in some ways, Anvil Publish suddenly makes it really straightforward to produce workspaces, and then in the workspaces makes those vignettes computable instead of static the way they were in a markdown document. I wanted to just say one more thing, which is, well, let's see. I'll go here. So, of course, Aaron has done this amazing, and others have done this amazing job of making the OSCA book available with many chapters for analyzing single-cell analysis. And I and many of you have probably gone through this document and cut and paste these commands into our R session and explored the analysis that's going on, adopting it one way or another. One thing that so this the book is actually now a package, right? And the individual chapters are markdown files. And what we'd actually like to be able to do is to transform those sort of static markdown files into a compute environment where we can actually do the compute that's implicit in the book, but actually, doing the compute interactively. And what Terra allows you to do as an advanced feature is, I'm going to just copy this thing here, is that the compute environment that you're running on is flexible. So I'm clicked on this thing in the upper corner here, this cloud environment. So the environment that I'm currently using is this R Bioconductor, R402 Bioconductor 311, a bunch of tidyverse packages installed. And it's running on a machine that has 4 CPUs and 15 gigs of memory. But I could decide to run it on a machine that has 96 CPUs and 360 gigs of memory. So I could easily change my compute needs. You'll notice that up here there's an estimate of the cost of that machine when it's idle and when it's working, so that this honking machine, this huge machine, costs about $5 an hour, whereas the machine, the default machine, which is still pretty capable for our day-to-day use, it costs about 20 cents an hour. So it's pretty interesting, right? So you can customize the compute environment. There's recently there's been this persistent disk that's being introduced that makes it great. So what this stuff is the virtual machine that you're getting, so the compute power. But you can also attach an arbitrarily sized, I think it's arbitrarily sized disk. So a 500 gigabyte disk. Maybe you need a 5 terabyte disk, which is only $200 a month. So if you had a need for a very large disk associated with your compute instance, you could do that, or even a very small disk if that were relevant. So you can customize the compute environment that you're using in terms of the size of the compute power and the size of disk storage. You can also customize what the virtual machine comes with. So I've chosen this R Bioconductor package, R402 Bioconductor 311 tidyverse. But if you're interested in using a legacy R, or using something like GATK and Python and a base version of R, but with no Bioconductor packages, you could have chosen that. And then just with this one here as well, just to get into the gory details a little bit, right? So it's a virtual machine, but on the virtual machine, it's actually running a Docker container. And the Docker container is actually created by us, by Nitesh actually, and follows the principles that are developed by Rocker and by the Bioconductor image derived from that. So it's kind of got the system requirements to install, all of Bioconductor. So any package that you need to install can be installed on this image, but it comes with just a selection of packages. And then that also points to an interesting idea or realization that if you have a Docker image with the right base configuration, then you can make any software available on Terra. So you can make an image that's available instead of running Jupyter. It could be running RStudio. And the plan is that there'll be, sooner or later, there'll be an item here that says, I want to run this, but not on Jupyter, on RStudio, so that you'll choose RStudio here and get an RStudio instance. But even at the moment, you can choose a custom environment. And what you need to do here is paste in the image. This is a Dockstore or a Google Cloud image, Docker image, that you want to form the basis of your computation environment. So Vince has made this Docker image that includes RStudio and a snapshot of the Orchestrating Single Cell Analysis book. And so if we swap our compute environment to this, instead of using our Bioconductor compute environment, we'll end up with a warning that we're not using fully approved software. I'm biting my tongue, and about who's doing the approving. And when you click on next, nothing happens. What it does is it'll shut down our current compute environment and then start up the new compute environment with Vince's Docker image. And that's great. So we'll just see how long it takes. I think it actually takes a little while, either 2 minutes or 10 minutes, to start up the new compute environment. And you can see that it's creating the environment, and you can see that this Jupyter symbol has been replaced with RStudio. So if we're patient enough, I think this will open. It'll say we have to wait 3 to 5 minutes. So we're probably not quite patient enough for that, but or at least I can talk and we can be impatient while I'm talking. So we're going to have our own RStudio environment that supports the OSCA book, and what you'll see is that actually the individual chapters are now available as markdown notebooks, and instead of having a static document, you can walk through this and recreate the analyses in the cloud interactively, and presumably adapt them to your own particular needs. So it's really transformed this amazing static document to a truly amazing interactive compute environment. So I think that's basically what I wanted to say. Maybe we can talk about things for a few minutes while this guy gets up to speed, and then go back and explore it just a little bit. So that's my introduction to Anvil. I'm happy to take any questions or tackle things that maybe struck your fancy.
Thanks, Martin. That's pretty interesting. Whenever I used like Amazon, or whenever I try to use Amazon and try to use sort of BioC parallel on Amazon, and specifically Multicore param, it would always complain. Like it would always just fail. I can't remember what the error message was, but it just kept on. It always failed. But this actually doesn't seem to be a problem for the OSCA book, at least when Vince built it, because I know there's at least one parallel section in there, and he managed to build it okay. So I don't know if you've sort of seen that phenomenon, happen where, I mean, I guess I don't know what backend they're using here, but where on the cloud, I guess some of the sort of details, like there's some level of abstraction about the compute resources that Multicore param doesn't quite respect.
Yeah, so I'm not actually sure about what your problem was. I would have guessed it was like blocked ports, and I bet depending on how you're using it on Amazon, it might have been sort of at the pure VM level as opposed to within Docker, and I bet Docker does a better job of protecting the ports that are exposed inside the Docker container from those that are exposed outside. So I bet that you wouldn't have that problem here. A tricky one.
Question would be more about what the Anvil Bioconductor package actually brings to the equation.
Well, what
you mentioned, for example, publishing vignettes or workspaces.
Yeah, when you're in what have I got here? When you're in a notebook, there are these elements of Anvil that you'd like to interact with, like this. So this is a bad example, but maybe you remember on Se-Yun's example, she had this table of samples that she was going to process, and you can do these things. You can create the table and modify the table in this clunky GUI-based way, choosing to add a table and upload a CSV file and so on. But actually, there's all of this, like the tables and running the workflows and moving files around in the from the VM to the bucket that's associated with the workspace. All of those things. There's an API that allows you to do those things, and so the Anvil package provides functionality that makes it easier so programmatically to do those things. Like you can list the files that are in your Google bucket, and you can access these AV files, the AV tables. You can access that table that before you had to load up as a CSV file. So you can load it into your R session, and then it's a tibble, and then manipulate it. Choose the columns that contain the word FASTA and discover, or take your own data. The MTCAR is a very valuable and enormous data set for which you need cloud computing, and import it as a table in the Anvil. So the Anvil package is providing sort of functionality that makes it easier to work with the Anvil components. I mean, actually, this could be pretty interesting. Like, if you had, say, the 1,000 genomes data, the table you might have imported from Gen 3, the table that contained all of the what I'd call phenotypic data about all of the samples. And what you actually wanted to do was find the individuals from a particular cohort who were of a particular gender and make a subset. And that's like, you know how to do that in R, right? It's just a straightforward thing to do. So you grab the table, do the manipulations, and then send the revised table back up there, instead of having to go through whatever the GUI contortions they'd have made you go through. That's kind of the functionality that this Anvil that the Anvil package does. Anvil publishes this thing. It's really useful outside of Anvil, but you can take an arbitrary R package that has a markdown vignette and translate it into a workspace. I also wanted to say so you can see that there are these different access levels. So I'm the owner of this book, but only a reader on some of these other packages under the account that I'm logged in on. And as the owner of a workspace, I can give other people access to this workspace, so I could share it. This is like my own, it could have been my own workspace that I only wanted to have access to, but maybe I wanted to share it with Kayla. Sorry, don't know about spelling last name. Kayla Morel, yes, good at gmail.com. I could share it with her and other people in my lab. And then you can see that I could share it in a way that allows Kayla to share it with other people, or to actually compute on the workspace, which would mean that we could jointly edit the document and develop our analyses. So if we're working like in a team-based environment, that could be pretty interesting. And you'll also notice that this one here, I've given permission to, this is called a group, the Bioconductor user group. And if I had, the account that I'm logged into doesn't have access to this, I don't have admin access to this group, but I can add all of these packages. The reason that this particular user has access to them is because this particular user is a member of the Bioconductor user group. So I can actually share, I could add Kevin to the Bioconductor user group, and then he'd have access to all of these packages as well. Kind of I'm thinking of this as like a step towards a fully public workspace when it was mature and robust, and I wanted to share it with the world. I think so. It's actually kind of interesting, right? So it's shared computing. That's kind of an interesting kind of idea. Yeah. So it looks like we've got to Vince's RStudio. It's running now. It's RStudio. It's in the browser. You can do all the RStudio things here as you want. And I think Vince has some instructions. I'm just going to go back and take a look at this. He says, install the current version of Anvil with this command. So I'll just copy that and install this. And while that's going along, he says, and then do this. And you can see this command, Anvil, is from the Anvil package. It's called localize. And what it does is it takes the OSCA book, which is on a public Google bucket, and it copies it over to my current virtual machine. And so this is actually, I don't want to update all of those guys. So this is actually kind of fun. It's actually copying, it's a cloud-based copy from one Google bucket to another. And because it's a cloud-based copy, there's no data egress. So there's no real cost to the process that's going on here in the background. And it's also pretty darn quick. We copied, maybe that wasn't so impressive, but I guess it wasn't so impressive, but we copied 355 files, maybe 50 megabytes of content from one Google bucket to another. But in general, the copying can be blindingly fast in the cloud. You can copy hundreds of megabytes in seconds. And then I guess I wanted to look at files. Maybe I need to just grab. This doesn't look so good. Here we are. So what we did was we actually copied over the OSCA book markdown so we could look at this Bach memory markdown. And here's the markdown, and you can see that we can then just do the analysis, run this step, run the selected line, and load the book. And then get ready to load single-cell RNA-seq and this is retrieving data from Annotation Hub, I believe, and then carry on in our interactive analysis. So it's changed the book from being a static document to a dynamic document with the compute resources necessary.
Martin, is this going to be is this one method that we could use to escape the constraints on the build machines for books?
Yeah, so we've been exploring that using the Anvil or in general cloud compute resources for building packages. And actually one of the things that Vince did was he got one of those 64 core 300 gigabyte machines, and he built all of Bioconductor software packages. It took him less than an hour, and so cost less than $3. So it is a very flexible way of building resources that requires like this that have maybe long compute times and so on.
I mean, I guess like this would only work for the Linux builds, right?
Yeah, it's kind of,
container.
Yeah, it's actually kind of interesting about how when you're on the cloud, it kind of changes things. So you don't really care about Windows, right? or even Mac, because you just need the one environment that's compatible with the Docker images. This opens up a lot of interesting possibilities. I mean, some of them aren't entirely new, but in the standard Jupyter environment, we've actually taken initial steps at making binaries of all Bioconductor packages, so that when you install a package from the right repository, you actually install the binary versions of the packages. So it's really fast, instead of, our HDSLib doesn't take months to install. It takes a couple of seconds for our HDF5 lib.
I may have something for you that's suitable for an offline conversation for 5 minutes. I just ambushed Hervé with that the other day, but he said he wasn't really the right person for that. In a nutshell, and sort of inspired by RSPM from our studio, a friend in Madrid who works with the Fedora project and has actually, as an isolated single person, built all of CRAN as RPMs for Fedora, all 15,000. We've done some work to pick up when R calls install.packages.
Yeah.
We have a little R package that traces that function, picks it up, and then does a little bit of Python Jingo to talk to the system package manager. So on Ubuntu, it's apt. On Fedora, CentOS, whatever, it's Yum, DNL, or whatever they're called. And it gives us what RSPM gives us, but with actual proper packages. So for example, on Ubuntu, I seamlessly go to the PPAs by Michael Rutter. I just say install.packages rstan, and then everything comes in, but fully resolved as actually the right binaries, which for your very controlled environment is the best of all sliced breads, because it's as fast as RSPM, but you don't have an oversight that, oh, this is a database connector package, and I also needed to bring that database handler in, and you can version all. It's pretty slick. So I just transformed all my CI runs using that, and I still use a maintained version of the really old one that started all of that. It's just a shell script that I curl, but because of that, I now have an independence layer that everything's just declared in that shell script. So I run the exact same code on Azure pipelines and on GitHub Actions and on Travis, because it's just Bootstrap. Then it's pull dependencies in, and then install, and then test. I have one gotcha though, because with the work with TileDB and the work with Aaron with TileDB Array and the dependencies there, all that works with R's install.packages. And when I went over to your work with BioC Manager and looked a little bit in the code, the installer there seems to be doing other stuff. So those calls aren't quite pulled yet. It looks, anyway, but we may be able to hook in there, and Iñaki has done really fabulous work. It just works. I have a little videos or GIF recordings on my website, basically just showing the two and then sort of showing off where RSPM goes belly up because it doesn't have system depends. And they do kind of the right thing, that they fix it after the fact with YAML declaration of what's needed, which allows them to do that outside of an OS dependency, exactly, because they have the apt-get installed there. And if something was needed on other platforms for RSPM, they can do it too, because they can inject the commands. But it's a looser, less fit coupling. And I completely agree with your viewpoint that on the cloud, we don't care about the portability. On the cloud, we just want one operating system, and we want that to just not fall over. And I think we have something for that. So I'd be happy to build on top of that or chat, but no, I just monopolized this for 6 minutes.
Yeah. No, that's great. Yeah. I did want to say that the way that we build the Bioconductor Docker image, it requires system dependencies, and we do rely on Nitesh is the we that relies on the RStudio package manager's database of system dependencies. And
right.
I wanted to say that they're actually, I'm not exactly sure where to find this, but there is actually an API, so you don't have to scrape the web page. You can query the API and find.
It's a REST service. You can get them, but it's just, it's a user-contributed service. They make no guarantees over it. It can go any moment, and it's really not that much harder when you know what the depends are, because once you have an R package on Crane or on Bioconductor, making a deb out of it is just the same. I mean, it's just a fixed set of scripts, and then you just push them somewhere. So it's easy to make this a little tighter. Notwithstanding the fact that they've done some things here that aren't bad. The other problem also is, of course, that when you're running R as a user, you can run install.packages because you have a library path anywhere where you have write permission. These apt-get calls require sudo. So implicitly, you're just handing sudo to everybody. We sort of have to do the same with BSPM, but it's murky. Just because you're crossing, application space and package space. But I think that there's a bit more work to be done, but it's good. Both of them, RSPM and what we call BSPM, are really nice to have and give us things that we didn't have a year ago, and it's slick.
Yeah. Yeah, cool. We're kind of at time, so we should probably stop, but I'm happy to stick around and talk more with people. So
it was very impressive. That was the single best demo that I've seen, because sometimes I still have these conversations with people who write vignettes in LaTeX and say, LaTeX over my dead body, not anywhere. The fact that Markdown is actually computable and that you can take the chunks and inject them into XML for Jupyter is a really good reason for doing it. That's very elegant. That's very nice. I mean, I hate Jupyter with a vengeance, and I really don't like it, but it's very prevalent, and at least we can accommodate those who are very, very tied to it. So it's good.
Yeah.
Cool. I'm going to bug out now, but thanks, guys. Thanks, Martin.
Thanks, Aaron.
Yep.